Hello. Hello, everyone. Oh, it's very few people today. Perhaps they haven't got the message. You know what? Let me just invite link. Zoom. Invitation. Just give me a moment. I'll post this to the groups. Okay, so hopefully people will start showing up. Okay, so today we are going to do some Euclidean geometry. So Euclid thought of this, and this is something that I always found that it's a pity that it's pretty much missing from UK schools. Okay, because like honestly, there's very little geometry studied in schools. Okay, so you don't. There's hardly any geometrical proofs or anything like that. When I was studying and I went to university, like one of the hardest problems in the entrance exams were always geometry. And for one reason or another, they started reducing the amount of geometry in school. So I'll try to amend that because this is something that you would definitely need for university. So hopefully you'll find this useful. So let's get to grips with some Euclidean geometry. So you should be seeing my screen. If not, do let me know. And I've selected 6 problems which are more or less similar to what you have in the assignment. Have you had a good look through the assignment? Have you read the assignment? 1 or 0, please, in the chat, just to understand where you're at. Okay, Maya, Jasmine. All right, do you see my screen, by the way? It says my screen share is loading. Oh, so you do see my screen. Okay, that's good. I'll restart it just in case. Is there a link to the whiteboard? There is. Okay. Okay, so the first question that we have is a triangle, and we're given the area of this triangle. It says that the area of the triangle ABC is 30 square centimeters. DE is on AC, so we can write DE belongs to AC, such that AD to DC is 2 to 3. So the ratio of AD to DC is 2 to 3. The length of DE is 9, and find BC. Okay. So we'll draw the line BD. Okay, so what we have is DE is a perpendicular, is 9, and the whole area is 30 centimeters squared, and the ratio of AD to DC is 2 to 3. Now, if the ratio of these is 2 to 3, and they have the same height, so triangle ABD and triangle DBC have the same height. Therefore, so the area of triangle ADB is equal to 1/2 AD multiplied by the height of this triangle, which we don't know, and area of triangle DBC is equal to 1/2 DC multiplied by H. Let's call this, okay, let's call this area 1 and area 2, just for simplicity. Now A1 divided by area 2 is the ratio of these. So it's AD to DC, which is 2/3. So the ratio of these is 2/3. So we can already find the area of, because we know that A1 plus A2 is 30 square centimeters. All we need to do is split this in proportion 2 to 3. And that tells us that the area 1 is the area of triangle ADB is 2/5 times 30, which is 12 square centimeters. And area 2 must be 18 square centimeters. Does everyone understand what I have just done? On a scale of 0 to 10, please. Okay. All right. Yes, that's very pleasing. A2. So we found A2. Right. So we found the area of triangle B. So the area of triangle BDC is 18. On the other hand, the area of this triangle, is equal to the base times the height equals 1/2 base times height. And it can be any height. So it's 1/2 multiplied by base BC multiplied by height DE, which we know. So we have 18 is equal to 1/2 multiplied by BC multiplied by 9. And therefore we can find BC. BC is equal to 4 centimeters. Okay, so we've used the property pretty much. We've used the property that the area of a triangle is 1/2 base times height. So very simple. I mean, this is not an uncommon problem for even GCSE, I'd say. Sometimes you get something like that. Not often though. All right, so let's do something more sophisticated. Okay, problem 2. We have an isosceles triangle ABC. The altitude from B is 10. The altitude from B is 10. So what does that mean? Well, that simply means that BD is 10. BD is 10 centimeters. The altitude from A is 12. That means AE is 12 centimeters. Find the length of base AC. So AC is what we need to find. Well, whenever you see a right angle triangle, it's probably looking at something like the Pythagorean theorem. Right. Now, so what do we have? We have an isosceles triangle. Isosceles, that means that AB is equal to BC, because isosceles. Like in geometry, you need to, whenever you do geometry, at least at COMPOS, you need to explain every step. You need to explain what you're doing. Because AB equals BC is equal to BC, so it's isosceles. Now, BD is perpendicular to AC. Well, you don't need to explain that, that's given, but you can say given. Right. Okay. So let AC equals X. So AC is X. And then and AB equals BC equals Y. So we make this equal to Y, and we make this side equal to Y as well. Okay. Now, if we look at triangle AEC and triangle BDC, they are similar. So triangle BDC is similar to triangle AEC. Why are they similar? Because they have two equal angles. How do I know they have two equal angles? Well, because this angle is, they have a common angle and they have a 90-degree angle. That means, but if two angles of a triangle are the same, that means all angles of the triangle are the same. Because if two angles are equal, that means the third one is equal as well. Okay, equal angles. And that means it follows that DC DC to the hypotenuse, to BC, is equal to the ratio of DC to BC is equal to the ratio of CE to AC. Substitute what we know. So DC is x over 2. BC is y. CE, well, it's CE. And AC is x. AC is x. Oh, sorry. That's not what we need. No. Forget that I said this. Because we know we have the ratio. We have the ratio of the sides. We have AE. AE is given to us. So the ratio of AE to x is the same as the ratio of BD to y. Therefore, AE is 12 divided by x is equal to BD, which is 10 over y. Oh, x over 2, sorry. X over 2, is it? Oh, no. It's not x over 2. Right. That means that y on x is 10/12 or 5/6. Okay. Now, from Pythagoras, we get from BDC, we have BD squared plus DC squared equals y squared. Now BD we know, BD is 10. So 10 squared plus DC, which is x over 2 squared, and equal to y squared. And that's our second equation. And now we have two equations with two unknowns, which I'm always trying to point that out. Two equations, two unknowns, usually means solvable. So from here, I get y is equal to 5/6 x, and plug that in, we get something decent. 10 squared plus x squared over 4 equals 25/36 x squared. 25 minus 9 is 16. 16 x squared over 36 equals 100. X squared equals 36 times 100 divided by 16. Notice that I'm not multiplying it out because I'll be looking for x, so I'm just taking the square root of that. 36 times 100, so 16, and I do 6 times 10 over 4, and now I can simplify it. So 3, 5, 1, that's 15 centimeters. So x is 15 centimeters. Is that what we need? Yes, that's what we need. X is 15 centimeters. So the answer is AC equals 15 centimeters. All right. How easy was that for you? So 0, super easy, 10, very hard. In the chat, please. Okay. So would you be able to do it on your own though? Easy to follow along, difficult to do. True, true. But see, you just need to look for these subtle hints. Pretty much you need to use similar triangles. You need to use congruent or congruent, I believe, triangles. You need to use, well, pretty much the properties that you've learned so far in school. And we're gonna do some more of these. Problem 3. The point where the hypotenuse meets the inscribed circle splits the hypotenuse into 2 segments of length m and n. Show that the area of the triangle is A equals mn. What would you do first? Can somebody help me? What's the first thing you would do? Actually, you have a problem very similar to that in the assignment. Can somebody help me? What's the first thing to do? Well, if you have a circle, probably interested in drawing radii. The radii of the circle. Yeah, pretty much, of course. That's the first thing that pops into mind. And actually, when you do that, a lot of things become very clear. Right. So let's say this is R, this is R, and this is R. Now, the point O, let's call this A, B, and C. This is a right angle triangle because it's the hypotenuse. That means it's a right angle triangle. And we know that the radius is perpendicular to the tangent. That means this is a square. This is R and this is R. Well, we'll need to prove that, but you can say that let's do it strictly. Okay, let's not skip steps. D and E. OD is the radius, and AC is the tangent. Therefore, OD is perpendicular to AC. Now, similarly, CB is perpendicular to OE. There's perpendicular, and therefore, as OD is equal to OE equals to the radius, therefore ODCE is a square. Okay, it is a square because the angles are 90 degrees and the sides are equal. Now, we know from the assignment as well, one of the reasons you will learn from the assignment, if you didn't know yet, that the center of inscribed described circle is the point where the angle bisectors meet. Right, so if we draw a line AO and OB, they're bisectors. And that means that this angle is equal to this angle, and this angle is equal to this angle. Right, so angle FBO is congruent, technically, is congruent to angle FBO EBO. Angle EBO. Congruent. And therefore, triangle OBF. Well, and because we have two sides, OF is equal to OE, and OB is a shared side. So from this, we can conclude that triangle EBO is congruent to triangle FBO. Is there a quick proof for that? The center of the inscribed circle is at the point that angle bisectors meet. Well, yeah, that is how you prove it. You can you have an angle. Well, you know that this is 90 degrees. You know that this is 90 degrees. You know that these are equal, and you know that this is a shared side. So you have side angle congruency. Okay, side angle congruency. And from here, then this is, and this is again side angle. Well, it's side angle. Side angle congruency. In a similar fashion, you can prove that similarly. Triangle AOD. Triangle AOD is congruent to triangle AOF. Okay, triangle AOD is congruent to AOF. So what do we get from this? Well, we get from this an important thing that, well, if FB is M, therefore EB is also M. Let's label that. This is M. And AF is N, and AD is also N. So AD is also N. And now we can use Pythagoras' theorem. Pythagoras is that N just a second, sorry. And Here's I'm about to use a statement that we haven't proved yet, but okay, so we can say that n, the area, we don't need the Pythagoras, sorry. That's not where I want to go. The area of a triangle, area, is equal to 1/2 base times height, r plus m, multiplied by r plus n. Okay, r plus n. And we can simplify that. 1/2 r squared plus rn plus rm plus mn. One half r, I'll factorize this bit, r plus n plus m plus mn. Okay. Now, in the assignment, from assignment 3, you will learn that the area of a triangle is equal to the half, the the radius of the inscribed circle multiplied by the semi-perimeter of the triangle. Area of any triangle is the radius, r is the radius of in circle, or in radius, simply put, the in radius, and P is the semi-perimeter. What is semi-perimeter? Semi-perimeter is, in this case, it's the perimeter divided by 2. So semi-perimeter is, well, you just add all the sides. So n plus m plus m plus r plus n divided by 2. Semi-perimeter. Perimeter. Sorry. Perimeter. Yes, you can ask. Yes, well done. You could do Pythagoras. I realized you can do. I wanted to lure you in the other direction, and as you can see, that the semi-perimeter is in fact 2n plus 2m plus r divided by plus 2r divided by 2, which is m plus n plus r. This is the semi-perimeter. And here it is. So we have area is equal to 1/2 multiplied by r times semi-perimeter plus mn. And we know that this is the area of the triangle. So area of a triangle is 1/2 area plus mn. So area equals 1/2 area plus 1/2 mn. And we have 1/2 area equals 1/2 mn. area equals mn. That the area is equal to radius times half perimeter. That's one of the problems. That's one of the problems in the assignment. So I might give you a hint, but yeah, try to figure it out. It's the assignment leads you quite it scaffolds you towards this solution. But this is an example of using it. Okay. But you can always look up the proof online. Right. Okay. Problem 4. Problem 4. So we're halfway through. That's very nice. Okay. So for problem 4, we will need one important result. A property of a bisector. Let's formulate this property. Property of angle of angle bisectors. Bisectors. All right. So if you have a triangle and you have a bisector in a triangle, so that's A, B, C, and you have a bisector. And let's say it's D. This, the property of angle bisectors is that the ratio of AB to BC is equal, let's put it as a proportion, AB to BC is equal to AD to DC. Did you know this? Did you know this property? 1 or 0, please. 1 for yes, 0 for no. Okay. Let's prove it. Let's prove it. So basically what it says that the bisector splits the opposite side proportional in proportion to the to the legs, to the sides, to the opposite side, proportion to the, what do you call it? Brain freeze. To the sides of the triangle. Proportion to the other side, other sides of the triangle. So it's quite an interesting result. How do you prove it? Well, you extend AB. So proof. Extend AD to point F such that FC is parallel to AB. Okay. Now, let's say that AD is M and this is N. Let AD equals N and DC is N. Okay. So we've extended. So these are parallel lines. So AB is parallel to CF and BF is a transverse. That means it follows from these two facts, it follows that angle CFB is equal to the angle ABF. Now, technically, you have to say congruent, but I'm not too fussed about it. Look, I mean, equal and congruent, you can say the angle measure is the same without saying that they don't have to say that they're congruent. Now, basically, it's Z angles. If you learned in school, Z angles, bam, bam, bam. Yeah, so this and this, these two angles are the same. That means that the angle, this is the same. But triangle, but also, yeah, so this angle is the same, and these two angles are the same. These are vertical angles. Angle ADB is equal to angle FDC. FDC, these are vertical angles, or vertically opposite angles. All right, so, and this is alternate internal angles. So that tells us the triangle ABD is similar to triangle CDF. Note that the order in which you put the letters matters. Yes, ABD and CF, ABD and CFD. Yes, it matters. That's why I got it wrong. CFD. Sorry, CFD. All right, that means that AB to CF, AB to CF is the same proportion as M to N, as AD to DC. But triangle BCF is isosceles, because this side, the angles are the same, as angle B is equal to angle F. That means BC is equal to CF. Means BC equals to CF. All right. So we're getting somewhere. And because BC is equal to CF, because we know that CF to AB is equal to DC. Okay, let's put it in a different way. Now AB to CF is equal to AD to DC. But CF is equal to BC. But CF is equal to BC. Therefore, I can rewrite this as AB to BC equal to AD to DC. Okay. What proved, basically. All right. What we need to show, AB to BC. All right, we're going to use this result. We're going to use this result in here. So we have triangle ABC. My notes. So what do we have? We have a triangle. AD is the angle bisector. Okay, so this angle is equal to this angle. OD is perpendicular to CB. Okay, so D is where the angle bisector meets. And O is, what is O? O is the point where the medians meet. Point where the medians meet. Right, so we know the properties of the median. Property of median. Is that EO to OB is equal to 1 to 2. And that's also in the assignment. That is proved in the assignment 3. Assignment 03. EO to OB is ratio to 1 to 2. Good. Now, OD is perpendicular. So OD is parallel to AC. Or EC. Let's rather say EC. And that means that triangle BCE is similar to triangle BDO. Therefore, the ratio of EC to OD we don't need that. Not EC. The ratio of EO to OB is the same as CD to DB. Okay, but we know that this to be 1 to 2. Yeah, so this is 1 to 2 is equal to CD to BD, DB. Okay, moving on. Using the property of a bisector, is that AC to CD is equal to AB to BD. No. Why am I doing that? To AB to DB. Or in other words, AC to AB is equal to CD to DB. But CD to DB is 1 to 2. We already know that. This is 1 to 2. And AC to AB, what is AC to AB? Somebody help me? AC to AB, something you should be very familiar with. AC to AB. Or perhaps I can write AC to AB. Would that help? What is AC to AB? I'm not asking for numbers. Yes, sin. It's the sine of the angle. It's sine B. Of course. AC to AB. That is sine B. So, in other words, sine B is a half. So B is 30 degrees. The only possible solution, because it can't be more than, it's a right angle triangle, so it has to be between 0 and 90. So it can't be 150, it can't be 390 or anything like that. Can't be minus 2 or 300, obviously. Minus 330. Yeah, it can't be minus 330. So yeah, B is 30 degrees, and obviously A is 60. A is 60 degrees, and C is 90 degrees, which you already knew. Okay, so got 4 problems done. 2 to go. Now, problem 5 is very similar to problem 3, although it is a little bit easier. Point where hypotenuse meets the inscribed circle. Okay, so we had this before. So we have an inscribed circle. We have the hypotenuse. Okay. And we have the center. It's R. That's R. That's R. Right. And you already know that this is R. This is R. So it splits into 2 segments, so length 5 and 12. So that means 5 and 12. So this is 12 and this is 5. We have already done this. Yeah, because these triangles are congruent. These two are congruent, so this is 5 and 5. So we use Pythagoras theorem. Pythagorean. Pythagoras. So we have 5 plus R squared plus R plus 12 squared is equal to 17 squared. So that's 25 plus 25 plus 10R. 10R plus R squared is R squared plus R squared plus 24R plus 144 equals 289. So 2R squared plus 34R plus 169 minus 169, 120 equals 0. So R squared plus 17R plus 60 equals 0. So multiply to 60, add to 17, is that 20 and 3? Well, that would be very convenient. 12 and 5. 12 and 5. R plus 5. R plus 12. Okay. R plus 5, R plus 12 equals 0. So R equals 5, R equals 12. R equals it must be minus 120. Minus 120. Okay. Yes. What am I doing? Minus 60. Minus 60. So, okay, that makes more sense. So that's plus 20 and a minus 3. So you have R equals minus 20, which doesn't make any sense, and R equals 3, which makes perfect sense. Yeah, R equals 3. And what do we need? Oh, we need the sides of the triangle. Well, okay, that's so answer. You have R plus 12, which is 15, 8, and 17. Okay. So there's very little proof here. Well, I mean, we skipped most of the proof because we've already done it in the previous one. And if you are doing two similar problems in one sheet, you can always refer back. You say, look, I've already proved that here. Okay, I've used that. This is how geometry works. If you prove one thing in general, you can use it again and again and again. And this is how any book in geometry is written. Okay. A few more things. Oh, this one is super easy, actually. Number 6. You'll be surprised how easy it is. But then we've run out of problems. Or maybe we'll have a chance to look at the assignment problems. The median drawn from the right angle of a triangle is equal to m and splits the angle in ratio of 1 to 2. Find the sides of the triangle. Okay, so we start from drawing, or we start from drawing a diagram. And the median drawn from the right angle, so the median drawn from here, equal to m, and splits the angle in proportion of 1 to 2. Well, it doesn't specify. So let's say it splits it in proportion of 1 to 2, like this. Oh, the median, of course, it has to be the median. So, so this has to be 2, and this has to be 1. Well, what's this angle? Can somebody help me? What's this angle? Can you already see it? $30. Very good. It's 30. Does everyone see that it is 30? Okay, it is 30. Right, and this is equal to m. This is the median. So this must be 60. 60 degrees. And 60 degrees. Let's call it ABC. BC, and this is M. Okay, now we need to use a circle theorem. Using a circle theorem. So well, let's write it down first. So how I would write it down if I was proving it, I would say angle ACM plus angle MCA is equal to 90 degrees, and angle ACM to angle MCA is equal to 2 to 1. 2 to 1. Therefore, angle ACM is 60 degrees. Angle MCB, MCB is 30 degrees. Okay, now circle theorem. If we have we know that this is theta. This is theta over 2. This is theta over 2. So if theta is 180 degrees, if theta is 180 degrees, theta is 180 degrees, then this angle is going to be theta over 2, which is 90 degrees. Basically, if this is the diameter, this is 90 degrees. Okay? If AC is the diameter, ABC is 90 degrees, which means that you can circumscribe a circle. You can circumscribe a circle. It's perfect. Where AB is the diameter. From circle theorem, AB is the diameter. And M is the center of the circle, obviously. And because this is M, this is also equal to M, and this is equal to M. Therefore, AM is equal to MB is equal to M. Therefore, AB is equal to 2M. So we found the first side. We find the hypotenuse. Okay. And basically, in any right angle triangle, the median drawn to the hypotenuse is equal to the half the hypotenuse. That's an important rule as well. In any right angle triangle, the median drawn to the hypotenuse is half the hypotenuse. And okay, this is 30. So if this is 30, and this is an isosceles triangle, so CMB is isosceles. CMB triangle CMB is isosceles. Therefore, angle MBC is 30 degrees. So this is 30 degrees. This is 30, then this is 60 degrees. Angle CAB is 60 degrees. And 60. CAB is 60 degrees. That means that AC is also M. That so 60, 60, and this is also 60, and that tells us that triangle ACM is equilateral. And that means that AC is equal to M. And then you can use various methods to prove that. Use Pythagoras or trigonometry, Pythagoras to show that CB is equal to square root of 3M. Okay. Type 1 if you think you've learned something new today. Just to. All right, good. So, okay. And on a scale of 1 to 10, how ready do you feel that you're to tackle the problems in the assignment? On a scale of 1 to 10, 10 being very ready, and 0 not ready at all. Tackle the problems in the assignment. 6, 9. Much more than you were. 6 to 7, 7-ish, 10-ish. Okay, good, very nice. We will have another one. We'll have another one in 2 weeks, or maybe actually next week. I'll talk to David. Maybe he'd like to do another one next week. I'm finishing off physics, so hopefully by Monday it will be published. Fingers crossed, but I'm working hard, barely resting. So it will be ready soon. Okay, I'll leave you here. I'll go and finish. I'll go to finish physics. And what will the difference? The geometry 2, which will be more proof based. So we will introduce you to axioms and just the concept of geometrical proof. Okay, how you approach any geometrical problem. It's going to be more general. Euclidean geometry 1 is just on triangles, and Euclidean geometry 2 is on everything else. All right, see you then. You're welcome.
Can I just ask a quick question?
Yeah.
How do you prove, what was that formula for the area of a triangle? A equals the semi-perimeter, that one.
It's in the assignment. It's one of the problems. Oh. Yeah.
So it's just, I've never heard of it before.
Well, it is an unusual one. There's another formula that you will consider. The area of a triangle is related to the no, it's that formula. So have a go. Have a go in the assignment. Okay. Have fun.